welcome back to Bear Squared. We're going to do a video on quadratic functions.
Hey guys, we're about to get started!
How are you feeling on what we're doing?
I'm excited to tennis ball and see the parabolic curve.
Ah, that's great. What's up, Beardos? I'm with Momo.
How we doing, Beardos?
Tried taping the two sticks together, but it didn't work. So, plan B, we're gonna blue tack the sticks to the wall. Try it, I guess.
See?
I just throw it from here.
Yeah.
How do you feel this throw will go? Do you think the first one will be successful, or?
I think we'll be very successful.
Okay, so before we see the throw, let's look at some examples. This is what we've done in class. So we've done a slow-mo of a tennis ball in motion. And then the ones that we've done on outside, here's an example of parabolic curve. Let's look at another one. So here's one more. I'm saying that I want it to cut through the x-axis. So here we go. Here's a ball in motion. And then we get to see another one here. This is really good. In fact, they're all good examples of parabolic curves, but we'll take this one as our final one so we can do the quadratic regression here. So let's zoom in and then let's overlay a grid on top of this with x and y axis, and we're going to use this parabolic curve to find the quadratic regression. So now that we've seen many examples of parabolic curves, what we'll do is we'll find the quadratic function. In order to do that, we'll go back to the video. So we'll take a look at the motion of this tennis ball as it's thrown through the air. And what we'll do is we'll take some coordinates, some points from this parabolic curve. So actually, if we start off here, the ball cuts through the origin at 0, 0. So we'll mark that as one of the points at 0, 0. And then if we follow the motion of the ball, it goes up and then it comes back down. Then it cuts through the x-axis again at this point here. So I reckon if you look close enough, that's about, it was not 65, it's going to be, I think about 64, 0. So we'll mark that point there at 64, 0. And then what we want to look at is perhaps the vertex, which is the highest point that the ball travels. And I think the highest point that the ball travels is probably about here, which if we look down to the x-axis is probably about 32, roughly speaking, about 32. And then that goes to the y-axis, I think is about 20. So it cuts the x-axis about 32 and the y-axis about 20. So that would be our third point. And then as we're looking through the motion, we can perhaps take this point here. I think the ball crosses right, where is it? Here we go. So I think the ball crosses about 10, 10. So the x-axis is about 10 and the y-axis, the value there is about 10 as well. So that's about 10, 10. And then we need one final point just so that we can do our quadratic regression. And if we look here, I think that's a good point about there, because you can see it's about, on the x-axis is about 60 and on the y-axis it's about 5, isn't it? So we'll take those 5 points. Now what we'll do with these points is try to find out the quadratic regression.